Hi, now I'm going to explain you about the next experiment, that is nothing but UART. UART stands for Universal Asynchronous Receiver Transmitter. This one is used for serial communication. So here we are using 8-bit Universal Asynchronous Receiver Transmitter. So this will be supported with RS-232 cable. This is nothing but the serial data transmission between DTE to DC. So DT is nothing but data terminal equipment, data communication equipment. So the data transfer between these two devices, data terminal to data communication equipment, using some protocol, that's something called RS-232 cable. So here internally this will be having UART port. So now I'm going to explain you how UART is working in PSoC and everything. So now this is a block diagram of UART, Universal Asynchronous and Receiver Transmitter. So this is a block diagram for UART. So already we knows that PSoC having internal UART, and UART is a combination of TX and RX. So separately we will be having both TX and RX in our user modules, but combination of these two UART is also available for you. So directly we can take UART, otherwise separately we can take TX or RX. Okay, that is your choice. So now I am taking directly UART module, that is nothing but combination TX and RX. So this is a block diagram for UART. So here in this block diagram, this will be consisting buffer, shift register and control register. So do you know the functionality of serial communication? That data transmit from start and data and stop bits are there. So that is nothing but data start and parity bit is there and stop bit is there. Okay, so for that purpose what we have to do is, so initially we are selecting some UART module in our user module parameters. So I am going to explain you how to select this UART module in user module parameters, and we need to do the some frequency calculations in this UART port. So for that purpose what we have to do is, so in this experiment we are selecting some user modules, something called UART. So only I am selecting UART. Okay, one UART. So this should be available in your user module parameters, user modules. So there we can select UART directly. So how to means, simply select, goes to digital communications, and here you can see like different types of digital modules. So in that we are going to select, otherwise you can select TX RX, but directly I am taking UART module. Okay, so now I am selecting UART. Okay, after selecting the module, go for interconnect view and place the module. So this should be occupying two blocks, two 8-bit module blocks, like one is a receiver and another one is transmitter. So this should be interconnect view. In this interconnect view what we have to do is, so we need to connect the port pins. So in our PSoC microcontroller there will be internally connected with 2.7. This port is internally connected with the transmitter, and 1.6 this should be internally connected with the receiver. Simply we need to place the jumpers at the UART2 port. So then internally these two port pins are connected with these two transmitter and receivers. Okay, now here very important thing is, so here we need to set the global resources. So generally our PSoC worked on PSoC. So before going to that, we should know what is baud rate and everything. So here in serial communication, baud rate is taking most major place. So in that what we have to do is, so in order to set the baud rate 9600 bits per second. So baud rate is nothing but number of bits transmit per second. So here we will be taking 9600 bits per second. So so generally our PSoC microcontroller, 8-bit microcontroller, then 9600 into 8, that is nothing but 76800. Okay, so since clock frequency it should be set to 8 times required baud rate, so that is nothing but 76,800. so how this came means 9,600 into 8, then we will be getting some 76,800 frequency. So this much of frequency we need to set the clock frequency, then only we can send the data as well as receive the data. So using this frequency dividers, we can set maximum up to 76,800 clock frequency. So now for that purpose what we have to do is, so in our global resources we will be having 3 volt frequency divisions like VC1, VC2 and VC3. So in VC1 what we have to do is, VC1 formula for VC1 is system clock by n. So system clock is nothing but 24 PSoC work done 24 megahertz, so 24 megahertz by 2. So here I am taking, for example, I am taking voltage divider. This is a n, something called voltage divider. So this I am taking maximum value is 1 to 16, so I am taking 2. Then I will be getting some 12 megahertz frequency. Again go for VC3 source. So VC3 is divided into source and divider. So source I am taking VC1 output, and divider I will be taking maximum divider is 256, so in that I am taking 156. Okay, so VC1 by n, so 12 megahertz by 166. Then finally we will be having 76,923. so this is approximately equals to 76,800. so now this will be approximately equal, then we can send the data as well as receiving the data. Now we need to synchronize these two frequencies for system clock as well as our microcontroller clock. So that's why we need to do this frequency divisions. So here I am taking 156. so this is one option. So based on your calculations, for example, one more calculation is also there, 156, otherwise 3 8 13, like this. 3 means VC1 equals to 3 dividing with 3, VC2 that should be divided with 8, and VC3 should be divided with 13. So then also we will be getting some 76,900 something. So that is also approximately equals to 76,800. So this is the calculation, frequency calculation for baud rate set for this PSoC microcontroller. So now finally these values are fixed in our